Now let me talk about the problems of magnification and minification that apply to in both forward and inverse mapping. So let's take this region. Of course, it's being copied over or warped in this region and be much bigger in this instance. So this is the issue of magnification, where all of the information from here is now much larger here. Of course, the problem that you can expect is going to be because of aliasing. There's not a lot of information here, much more information here, so it will be blocky and choppy. In case of the inverse, we'll have a region, and what's happening really is basically this part is going there. So of course now I have to figure out how to do computation of this from here, and of course this is a problem of minification. To solve this, what I would do basically is kind of even discretize this region here and copy out the discretized information from here to there. So this allows me to now generate a much larger thing, and of course I would take all of the values from here and project them here, and similarly this one would be here, and that's how I can actually start doing. And of course we can do a variety of other things that allow you to basically anti-alias this. However, in this case, of course, we would actually have problems because we don't exactly know how to do the inverse warp. Again, we'll talk about that briefly again in the next few slides. But one thing I want to point out is that in essence what we want to do is we want to be able to sometimes figure out the best computational mechanisms to support it. There's a lot of literature of this kind of stuff in texture mapping and stuff like that, and computer graphics that's aimed at addressing this problem of both forward and inverse mapping. One specific method I want you to look at is a two-pass transform that basically does the geometric transforms that we had looked at in the previous slides, which was basically the whole concept of doing rigid and affine warps, and then basically being able to do smaller warps to be able to get smaller differences. And by combinations of those and the fact that these current processors can actually deal with these geometric transformations much better, you would actually have much quicker ways of deforming regions and images to be able to generate nicer artifact-free visuals and videos.